In the redox titration lab, you're going to use potassium permanganate to determine the molarity of iron in a solution that you don't know the concentration of. And you're going to do this using titration and a redox reaction. So, let's talk about the reaction that you're going to do. So you're going to take a solution of potassium permanganate and you're going to react it with iron. So this is the reaction that is happening, but we have to balance it. Now there's a couple things we have to take care of. We of course have to balance the number of atoms on each side, but we also need to take into account the charges. So let's go through and see what the charges are on each of these elements, and then we will proceed from there. So we can see that hydrogen has a positive charge because that's written. And the permanganate ion, we know that oxygen always has a 2 negative charge unless it's part of a peroxide, which it is not in this case. So oxygen has a 2 negative charge, and there are 4 of them, which gives us a total of 8 negative. But this ion has to have an overall negative charge, which means the manganese would have a 7 positive. So our charges are given to us for the iron and the manganese and the iron on the other side. So if we look at our water, we know that oxygen has a 2 negative charge and hydrogen has a positive charge. So the two things that change their charges are manganese and iron. So manganese goes from a 7 positive to a 2 positive. So we know that it had to gain electrons for that to happen because electrons are negative particles. So in order for us to become more positive, then we had to have gained some electrons to offset this. So this is reduction. Fe2 positive to 3 positive, we lost an electron. We became more positive. In this case we became less positive with the manganese. For iron we became more positive. So oxidation. So we're going to split up our reactions. And we're going to write the reduction and the oxidation reaction. So if we take our oxidation reaction, we have iron 2 positive gives us iron 3 positive, and we lost 1 electron. Then if we do our reduction reaction, we have manganese, actually it's the permanganate ion rather, I should say, gives us manganese. But in order to balance this, if we haven't talked about this already in class, we will. We also have to take care of the oxygens and the hydrogens. The way that we take care of oxygen is by adding water. And then since I've added water to this side to balance the hydrogens, I need to add H positive on this side. So now with this reaction, the other thing I need to include is the number of electrons that we... Where did that one go? There we go. That we gained or lost. So we went from a 7 positive to a 2 negative charge. Which means that we gained 5 electrons. So we need to take that into account as well. Now before we do anything else, let's go ahead and balance our atoms on each side. So we have 4 oxygens on this side and only 1 on this side. So I need to put a 4 in front of the water. And then when I do that, now I have 8 hydrogens on this side, but only 1 on this side, which means I need to put an 8 there. So that balances out all of our elements. The next thing that we need to do is we need to take into account the electrons. In order to add these back together to get our overall reaction, the electrons have to cancel out. So I have 5 electrons in the manganese reaction. I need 5 up here in my oxidation reaction. So I'm going to have to multiply that by 5. And when I do that, now I have, for my oxidation reaction, 5 iron gives me 5 iron 3 positive plus 5e negative. And then my reduction reaction, I can copy the way I've balanced it. So now, when I add these together, and my pen is not working again. When I add these together, the 5 electrons on the reaction side cancel with the 5 electrons on the product side. So that gives me, for my overall reaction, AH positive plus MnO4 negative plus iron 2 positive gives me manganese 2 positive plus 5 iron 3 positive plus 4 waters. So that's my overall reaction that I'm going to be working with. So what you're going to do is you're going to get some potassium permanganate, and you're going to fill up your burette with that. Remember, with a burette, we read it from the top down, not from the bottom up. And you're going to get 5 milliliters of your unknown iron solution. And you're going to add some phosphoric acid and deionized water to make your iron solution. You're going to titrate this until the pink color stays in your Erlenmeyer flask for at least 20 seconds. And then you're going to repeat the titration 3 more times with a fresh iron solution in order to make sure that your results are reproducible. So if you get any of the permanganate solution on your skin, you want to wash it off. If you get it on your clothes, it's probably going to leave a stain because it's a pretty dark color. So you want to be careful with that. So let's take a look at your calculations. You're going to record the molarity of the potassium permanganate solution from your bottle. And then what you're going to do is you're going to determine the volume of permanganate that you use. And then using your reaction, you're going to okay, let's see if I can fix my stylus here so that we can go through the calculation. So you're going to take whatever your volume of your potassium permanganate that you used, And you're going to, and I should probably write this a little bit smaller so that hopefully we have enough room to fit this in. So your milliliters of potassium permanganate, and remember that molarity is moles per liter, so that means we need to convert the milliliters to liters. And then 1 liter of MnO4 negative. And you're going to fill in whatever your concentration of potassium permanganate is. So this number here, you're going to obtain from the bottle. And you're going to fill in your molarity there. And then we know from our reaction that 1 mole of MnO4 reacts with 5 moles of iron 2 positive. So this is going to give you the number of moles of Fe2 plus that you had. And then to calculate your molarity, remember that you started with 5 milliliters, but you diluted that to 40, so you have a total volume of 45 milliliters. So to get your molarity, you're going to take the moles of iron divided by, you have 45 milliliters of solution, which is 0.45 liters, and that's going to give you your concentration of iron 2 positive in your solution. So you are going to do that for all 4 trials, and then you're going to calculate an average by adding up those molarities and dividing by 4. So that is the redox titration experiment. Make sure that you submitted your purpose and procedure on Canvas, and I will see you in lunch.